Okay, so today we're going to talk about the Object Client-Server Framework, which is the framework which you started to study this in the lab, in fact. You should, at this point, be in the middle of the lab. You've taken a look a little bit at the OCSF and starting to do some work on the simple chat system. And the idea is that I'm going to give you a detailed discussion of how it works today and all the little details of it, which will then allow you to go back into the lab and to have a much better understanding as you finish that lab off. There are three main classes in the lab, in the framework. One class on the client side, abstract client, okay, and two classes on the server side. Okay, the main class that you're going to be interested in is abstract client on the client side and abstract server on the server side. And you're going to, in fact, be creating subclasses of those and working with subclasses of those. But connection to client is a very important auxiliary class on the server side. What I'm showing here in this list is the important set of methods available on the client side. You'll notice that one of these, handle message from server, is abstract. It's in italics, which means it's abstract. Okay? We're going to take a look at what some of these other methods do. Open connection, send to server, close connection, etc. in a few minutes. But basically, they have to do with the process of the stuff that we talked about in the last lecture. Starting up the client, connecting to a server, sending messages, and responding when messages come back from the server. There's further mechanism inside that sets up the thread for communication with the server and stuff like that. On the server side, we've got more, because servers are intrinsically a bit more complicated than clients. So we have things like listening, which means, okay, we're going to start the process of listening for new connections, and stopping that if we want. Okay, closing the server entirely, sending messages to clients, in this case all the clients, and then responding to various kinds of things that happen during the course of the execution of the server. And, as before, there is one abstract method, handle message from client. Okay? Now, if it's as an abstract method, that tells us for sure, one thing we definitely know, is that this is going to be something that we have to write. We have to write a code for that in the subclass. Okay? And so, therefore, we know that that is a slot. Remember, we talked about the concept of frameworks, and we said that in frameworks you have hooks and slots. So that is a slot. And this connection to client, an instance of this is created for every single connection to every client. Okay, and this little asterisk here means there's a one-to-many relationship. So this is this is what is called the UML class diagram. We'll talk a lot about the details of the UML class diagram in a couple of weeks, but this is one of your first tastes. We saw a few tastes of that earlier on. This is another taste. I think you should understand the concept. You have basically one of these in the client, one of these in the server, and many of these also in the server. So let's start talking a little bit about how software engineers work with this framework. Okay? First of all, and this is the cardinal rule, very, very important rule, software engineers never modify these three classes. Okay? You will lose marks if you make any changes to those three classes. It's absolutely not the thing to do. Verboten, forbidden. Okay? That's one of the cardinal rules of frameworks. A framework is provided to you. You have access to it. You might be able to edit the files, but that does not mean that it's a reasonable decision to make changes to it. If there are bugs in it, you report the bugs, and the person who's responsible for the framework fixes the bugs. If you start making changes, you're creating your own version of the thing, and it's no longer a legitimate framework anymore, because now you're spreading out different versions, and each person's got their own version, and we don't have this ability to have this body of reused code that one organization is responsible and in charge of. Okay? So don't make changes to those classes. Anything that you want to do that modifies the behavior has to be in a subclass of one of those classes, or more than one of those classes. Okay? it turns out that in this lab, and we'll just come back for a second, you'll make subclass of the abstract client. In fact, you're given a subclass of the abstract client. You'll modify it, make additional subclasses. And abstract server, you won't even be making subclasses to connection to client. Connection to client you will strictly use. You won't be needing to make any changes to that either, nor make any subclasses of it. Okay, so what do software engineers do? Back on slide 27. They create subclasses of the abstract classes. Okay, they call the public methods in code that's written either in those subclasses or in other classes that they create in the system. And they override. They override hooks if there's any hooks, and there are a few here, in order to add additional functionality that the hooks provide. Well, hooks provide no functionality, they just do nothing. And the slots are abstract, so they have to be overridden or explicitly they have to be written. You know, that's the concept. Generally speaking, with slots, we don't say overridden because there isn't anything to override. It's just an abstract operation. You have to write code, basically. That's the concept. Okay? So these are the things that you're going to be doing in this assignment with respect to OCSF. And in fact, you know, this assignment is going to continue. We're going to do more sophisticated stuff. Towards the end of the term, there is the opportunity to do a little bonus piece of work where you're actually going to allow the exchange of images, drawings between various people using the same framework. This framework can be used for any kind of client-server communication. Okay, you're using it for a chat program. We have another demonstration application where it is used for transaction processing for small hotel management. And it could be used for anything. It could be used for... because it's Java, it probably wouldn't be used for something which requires extremely high-speed communication, where there's a lot of processing going on at the client and the server of the messages. I would, you know, although with today's fast computers, it might even be capable of doing, you know, something like, you know, handling video or audio. I would suspect that it wouldn't be fast enough to deal with those kinds of messages. But any kind of transaction processing or systems that require messages that aren't as intense in processing requirements as video and audio probably would work. It would be interesting to try it for audio, actually. I have some students working in their fourth-year projects who are using it for the basic basis for a system for analyzing chess, for example, as well, where different people get together and work on chess together.
Sir,
Question?
what are the terms that we're allowed to change?
Any subclasses, and we'll get to that later on, because later on we're going to talk about simple chat. You're allowed to change any classes other than the ones in the OCSF itself. You're allowed to change application classes, okay? You'll be given the simple chat application, and that we'll talk about a bit later on this morning, okay? Okay, we're going to talk first about the client side, then about the server side, okay? So that you understand both of them. So the client side of the framework has a single class. Your client-side code, your application code, has obviously got more than that because it's got a subclass at least, plus several other things. It probably has a user interface class, and maybe a client could have hundreds of classes. But from the framework's perspective, its contribution to the client side is one class. Okay, at least at this part of the framework. There is another extension of the framework which we'll get to much later on, when we're talking about Chapter 6, which adds additional facilities to the framework. But you can just not worry about that. You might see there's an additional set of classes in what's called the observable layer, but you can ignore those for now. Okay, so the single class abstract client must be subclassed. Okay, in order to use it in an application, you must create a subclass of this. Just a request, people who come in late, if you could try and let the door close slowly, rather than slamming it all the time. Appreciate it. Okay, so any subclass that you provide for whatever application you're providing has got to provide an implementation for this abstract method, handle message from server. Okay? Handle message from server is abstract in the framework. And it is the core class that gives your application some kind of different functionality. Every server is going to do things differently, and every server is going to use a different protocol. Okay? So handle message from server is effectively saying, what kind of protocol, what kind of language am I going to understand in the messages that come across from clients? Okay, and that's going to be completely different in every application, and therefore you've got to write the code for that. There's no point us doing a dummy version that does nothing, because a server that does nothing is useless. So we make it completely abstract, and each application can do whatever they feel like. Okay? The second thing about the abstract client is that it implements the runnable interface. We talked about that the other day. And the runnable interface, what that is it's an interface that transforms this class into a thread class. We talked about threads, right? We said a thread is basically a little mini program that runs inside the system, okay? So, because it has a runnable interface, it has a run method, okay, in it, and that contains a loop that controls the lifetime of the thread. This run method is actually in the abstract client class. Okay? So you don't write your own run method. The run method is all there. It all does everything it ever wants to. You don't override that. You don't touch that. That run method is up there in the abstract client class. Okay? And we'll see in a while what it does, how it works. Okay? So, we saw this in the diagram a while ago. This is a breakdown of a little bit more detail of the methods in abstract client. This, in fact, is the public interface. There are other methods we'll get to in a few minutes. These are the ones that you are going to be able to call from your application code. The first one is open connection. Okay, we're going to talk a little bit in a couple of slides about how we use these, but I'm just going to give you a little brief introduction to the concept of each of these now. Open connection is called by some part of your application code when you want to tell the system, we can start accepting, or we can start, we want to start communicating with a server. Okay, we want to open a connection to a server, and that, the server will then accept our connection, and then we will start accepting messages from the server and be able to send messages to the server. So we want to open a TCP/IP connection to some server. And we'll be providing some arguments to these as well. We'll see those. Closed connection is the inverse. It's saying we want to shut down the connection to the server in a graceful way. We're not just going to sever the connection. This will shut it down in a systematic way. And send to server. Okay, send to server is actively saying send a message. In fact, it's an object client-server framework, so you can send an arbitrary object. In the code we're using in this class, in this lab, we're going to be sending instances of string, but you can send any other kind of object if you want. Okay, beyond these are the controlling methods, because these are the methods that are actively used to tell the client what to do, okay? To change its state so it's behaving differently. Opening, closing, sending messages. These are active things that you write in your algorithms for doing stuff, that do stuff that has an interaction with the server. Okay? The server will pay attention to the results of each of these things. Okay? Hopefully it'll accept the open connection request. It'll acknowledge the closed connection, and the server end, that will also shut down the connection at the other end, and the send to server will hopefully cause some response from the server. The server will react to that message arriving. The accessing methods are, you call these to obtain information only, okay? They don't actually perform any function that causes changes. They just get information, like get the values of variables. So is connected. That'll return true or false, and it'll tell us, in fact, whether we are connected or not. Okay? We might be wondering, it's been a while, are we still connected? It's a check you can do in an algorithm before you try and send to see if you're connected or Get host says, well, exactly who are we connected to? Set host says, well, next time we try to connect, we're going to use this host. Get port says, well, you know, what port are we connected to? And set port says, next time we try to connect, we're going to use this port. And get INET address says, okay, well, we said we're going to connect to CNN.com, but, you know, exactly what is the numeric IP address of that connection that we're connected to? Okay? So these are informational messages that you can send, okay, to the instance of the class that you create. Now, let's get the concept right. You're sending these messages to the instance of the client, right? So we've got this abstract client superclass. You create a concrete subclass of that. Okay, what has the instance? Well, the instance is an instance of your concrete subclass that inherits all the stuff from the abstract superclass. So you're going to send these instances to the class, these messages to the instance of the class that you create. Okay, they might be sent by code inside that class that you've written, or they might be sent by other classes that are maybe a user interface class, or classes that are elsewhere in your client side of your system, to the instance of this subclass that you create. Okay? The implementations of these things are all in the abstract client class. Okay? These are the code is concrete in the abstract client class. They provide all this stuff, okay, in that class. So it's inherited into your subclass, and in your subclass you have more stuff, some of which can call these things. Okay? Okay, you'd understand that well if you have a good understanding of the stuff that we've talked about in the basic object-oriented principles. Any questions? All right. So we were looking at the public interface. The public interface is what we call the API, or the set of services that are provided. In addition, we have a couple of methods that are what are called callback methods that actually do nothing. Can anybody tell me what a callback method that, or what a method that does nothing, that may be overridden, is called theoretically? What is that? We talked about that the other day. Anybody remember the term we used? I also mentioned it this morning as well. No, not a, if it may be overridden, it's not a slot. It's a hook. Right, okay. So these first two methods, connection established and connection closed, are hooks. And the method that must be implemented is the slot. Okay, that's the term we use. So a hook is something which is implemented. There is a concrete implementation in abstract client. But it does nothing. It just returns immediately without any execution at all. Okay, connection established and connection closed. What do they do? Well, connection established executes. It is called by some code in abstract client, in the run method, in fact. Okay? Whenever a connection is successfully established with a server. Okay? So at some point in time, you have called open connection, and at some point a little bit later, maybe a few milliseconds later, once the message has gone to the server and the server has accepted the connection and sent a response back, there is some information that's processed in the socket instance that we talked about last day, and that causes the triggering of this connection established. Okay, and if you look at the code in the run method, you'll see how that's done. Basically, what happens is that when the accept or the read method on reading on the input stream returns the first time. Actually, no, I correct myself. Connection established. Yeah, it would be when you try an open connection. Sorry, when you try an open connection, when that whole thing responds, it will call connection established. Yeah. Okay. So connection established is called and does nothing, and you don't have to do anything about it if you don't want to. But there is an advantage of overriding connection established to do something. You can, for example, override connection established to display some information on the screen, to tell the user, here is the connection that was established. Or to do any kind of processing you want. Maybe as soon as the connection is established, you want to set some variable or set some data or something like that. Okay? Similarly, we have connection closed. Any time the system determines that the connection is closed for whatever reason, okay, this will get called. You don't have to do anything with it. But if you want to override this method to cause some execution whenever the connection is closed, okay, at that point in time, you can make your overridden version of connection closed do something interesting, like displaying a message to the end user on the user's screen. Okay. And finally, handle message from server. This is called with an argument, which is the object which is being returned from the server. So every time the server sends a message, this will get called. And you have to write some code that says, what am I going to do with this thing, this object that I've got? The server has sent me an object. What am I going to do with it? I have to, I have to make a decision. I'm going to presumably look inside the object and do something interesting with it. And if the protocol is behaving correctly, you're expecting this message from the server, and you're going to do something that performs the function of your application. Okay? So this will presumably call a bunch of important functions in your application that do useful things. So if the message is a new reservation request for an airline system coming in, you're going to go to the database and start processing that request. And then eventually, you're going to, in response to this message from the server, you're going to send something back. Actually, that responding to a request for a reservation sounds more like server function. It might be a response from a server saying, we have completed your reservation, here are the details of it. And then you might display those to the user or do some other kind of processing. Okay? So these are the pieces of code that are callback methods. They're called callback methods because they get called by the code of the framework itself. Okay? Whereas the previous set that we looked at, the public interface, your code calls these actively. The callback methods are called for you by the code in the framework. You don't actually call connection established, connection closed, handle message from the server. You shouldn't call those things. Those are called for you. You just write code that executes when these get called. Okay? Any questions? All right. So if you have the job of designing a system using this framework and you want to use Abstract Client, what do you do? Well, first thing you do is you create your subclass. Okay? You create your subclass of Abstract Client that's going to provide the functionality for the real system. Abstract Client is abstract. You've got to create a concrete class that will have a real instance that will inherit all the Abstract Client stuff that will do something real. And you must implement handle message from server in order to take action whenever you get these messages. And your code, somewhere in your client side, it must somewhere create an instance of this class. Okay, there's got to be code to create an instance of this class that you've created that's a subclass of Abstract Client. Otherwise, without an instance, it'll never run, right? There's got to be an instance created. And somewhere, something has got to call open connection. Because unless we actually call the open connection somewhere, we're never going to connect to any server. And if we never connect to any server, we're never going to get any calls to handle message from the server, right? So something's got to call open connection to get the whole thing going. Okay? And then we've got to do something somewhere that presumably, most of the time, in almost all kinds of servers, will actually send messages to the server. Because in most systems, unless we send a message to the server asking for something, we're never going to get a response back from the server saying, here's the answer. Okay? So we've got to have code that does these kinds of things. a very, very few kinds of servers might operate on the following principle, that you connect to the server, and that's all you do, and then the server randomly sends you information. So for example, I could imagine, abstractly, a security system, that all I do as a client is I connect to it and say, okay, I'm connected. And then I wait. And every time a burglar breaks into my house, the message gets sent from the server to the client saying burglar just broke in. But I never actually send anything to the server. I just get messages from the server. I could imagine some abstract system working that way. It's a bit weird. Most systems would be much more sophisticated and send messages backwards and forwards. Okay. So generally speaking, the client initiates a connection and also sends a message to the server to get some response. Most systems will work that way. And in most security systems, the client is the one that's detecting the burglars, as opposed to the server. It would be pretty strange, I think, to have it the other way around. But I could imagine a sort of system which had some clients that are, say, maybe I've got some clients that are detecting burglars, and they send messages to a server, and then that server sends messages out to the police and the fire department, and those departments have their own specialized clients that want to be notified by the server whenever any break-ins occur. I can imagine that kind of structure, and that will be this case where they just connect and wait for messages coming in. Okay, so to recap, we've created our concrete subclass, we've implemented handle message from server to do work, and somewhere, either in handle message from server or something that it calls or some other code somewhere else, we've created a class, an instance of this class called open connection, and we've sent some messages to the server. Finally, optionally, and these two things are not always required, but it's useful sometimes to do these kinds of things. We've implemented the connection to closed callback and the connection exception callback. All right? So we implement these things in order to display the status, typically, of whether we're connected or not. Okay, so maybe we display a big red mark on the screen every time the connection closed callback is called to say, that we're not connected, warning people we're not connected. Oh yeah, and by the way, connection exception wasn't in the previous list, but it's just another one of these callbacks. Connection exception is saying the connection was closed surprisingly, unexpectedly. Okay, connection closed was normal closing. Connection exception is somebody cut the network cable. Watch out, the burglars are really breaking in because they've cut the network cable. Something like that. Okay, actually, it might mean the server's gone down. We talked about protocols and being polite and being rude. Well, this is the rude. When connection exception is called, something rude is going on, whereas connection closed, something polite is going on in terms of saying goodbye and have a nice day. Okay. So that's how we would, as software engineers, use the abstract client. You'll find in the simple chat system we'll look at in a while that most of this stuff is actually done in the very, very simple code that you're given for chatting on the client side. A brief look at the internals inside this class. Okay? We have an instance of the socket class. We talked about that last lecture. The socket class is this class that holds information about the end of the connection. All right? We also have an object output stream and an object input stream. We saw that the other day as well. And we have the fact that this is going to be a thread. There is a thread instance that is basically built into this system that is using the full standard thread functionalities there, and abstract client has a run method that is running in a loop. You go look, you see that loop, that run method. If you wanted, I encourage you to look at abstract client and its implementation. Understanding the implementation of it will give you a better understanding of how client-server systems work from the internal perspective. Okay, so take a look at that code. By the time, say, the midterm comes around, it would be very advantageous for you to have had a thorough understanding of it. It's not always required that people look at the internals of framework code. You can use a framework by merely understanding its API and its callback methods, you know, its slots and its hooks. Okay, as long as the specifications are there, you could understand it and work with it. But for this course, because your job is to understand software engineering in a bit more depth, I would like you to look at the internals of this thing. Another thing that's in the internals then is the fact that we have a host variable and a port variable. Okay, these are instance variables, okay, that will be filled with values of the host and the port of the server that we're connected to. Or if we are about to connect to a server, they will have the host and the port of the server that we are, you know, attempting to connect to. And in fact, these are the values that are set by set port, set host, and that are returned by get port, get host. Okay, so the concept, I think, relatively straightforward. And last lecture we talked about how do you do client-server stuff in Java. This just actually is the real code that does it. So you don't actually have to write any socket code. You don't have to actually write any object output stream, object input stream code. That's all written for you. Okay? So Java has facilities there, but you don't even have to use those facilities. You just have to use the facilities of the higher, more abstract level of this framework. And that makes your job even easier. So Java's already easy. This makes it even easier. Okay, let's look at the server side then. The server side is a little bit more complicated because it has two classes instead of one. One class is abstract server that has a lot of similarities to the abstract client. It also acts as a thread, so it has its own run method inside it and so on. But its job is to listen for new connections. Okay? Then we have a class connection to client. And these also, instances of this also act as threads. And they are communicating one instance per connected client. We talked about this notion of having multiple threads in the server. Well, here we are. We have an instance of this, abstract server thread, and multiple instances of the connection to client thread. All right? As with the client side, we have a public interface, an API, set of methods. Some of them have the control function. So in our server, when the server starts up, we want at some point to call a listen method that says, the server is now running, we've initiated, maybe we access some information from a database, we've set up whatever we want to set up, we're ready to go, fire up the listen method. As soon as we call listen, then clients can start connecting to us. At some point we might say we want to stop listening, we're preparing to shut down, or we're temporarily stopping connections because we're overloaded. Whatever the reason is, we can control the functionality of the system by calling stop listening. We can also call close. Close is more powerful than stop listening. Stop listening says don't accept new connections temporarily. Close says not only don't accept new connections, but also boot off the clients that are connected. Okay, so it's more powerful, and normally you would do that when you're preparing to shut down the server entirely. And then there is a send to all clients. Send to all clients is it has the effect of broadcasting. You can call it and pass an object as an argument, and that object will get sent to every connected client. Okay? It's there as a utility. It's not required to use this by any means. In fact, there's only really two methods that you're required to use in these controlling methods. You're required to listen, you're required to close before you shut down. Send to all clients is strictly a utility. It's there in case some concrete subclass feels that it will be useful to send the same message to all clients at the same time. And it just goes around in a loop saying, okay, here's a list of connected clients, okay, send, 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 send. Okay, that's what it does. Simple. In addition to these controlling methods, we have accessing methods as in the client side. Accessing methods get the status. They tell us information about what the server is doing. So, is listening says, are we actually you know, in the process of listening for connections or not. You know, maybe we forgot whether we were or not. Or we want to double check to make sure that it actually is actually occurring. Get client connections says, give me a list of the client connections, and so that I can do something useful with that set of connections. Maybe I want to go through those connections, printing out the names of all the people connected, or I want to send a message to a subset of them. I can send a message to all of them by saying send to all clients. But if I want to send a message to just a few of them, or search for a client that matches a particular pattern, or has a particular name, I've got to call get client connections and then go searching through the list for certain criteria. Okay? So in actual fact, we'll see that this get client connection will use the iterator mechanism that we talked about the other day. And it's actually, so get client connection is quite a sophisticated mechanism, whereas get is listening is simple. Get port is simple. Get port is just returning the value of the port that we connected on. Set port is saying, next time we start listening, listen on this port. Okay? So one thing, here's a sequence I could do. I start up, I say set port 5555. Fine, listen on port 5555. Then I say stop listening. Then I say set port 5599. And then start listening again. And now I'm listening on a different port. I'm really throwing my clients off because they will have no idea where to connect. But hey, you know, I can do that if I have some protocol that says switch ports every now and then to stop hackers breaking in or something. You know, maybe what I've got is a system where I'm detecting hackers, and all that hackers have got caught in wind of what port I'm on. So what I do is I tell all my trusted, legitimate clients, I'm going to switch port. You're going to have to disconnect for a while, and then try connecting back in 20 seconds. I'll be back on a different port. Okay? It's like switching channels on the radio. Okay? As long as my clients know that I'm going to be back on a different port, they can try connecting back again once I successfully come up on that different port. I can do that. I don't know of real systems that really do that kind of thing, but hey, the facilities are here if you want to try that kind of mechanism. Okay? Yeah?
When you call set port method, does it disconnect all the clients?
No. Set port does not disconnect. Set port only says, next time I connect, you're going to use this port. Okay? So all it does is set the port variable. And it's designed merely to get you ready to connect next time. Okay?
So when you stop listening and you listen again,
it will automatically still use the same port. Yeah.
it's using the same port, but those clients already connected. We're using a previous port.
The default operation, okay, is I set port at the beginning when I first start up, and that's it. And if I start listening, I'm listening on that port. If I stop listening, my clients are still connected. I should theoretically be able to start listening again, and that will be just on the same port. Okay? Okay, so stop listening merely says I'm not going to be able to listen. My client should theoretically still be able to continue all their communication while I'm not listening. Stop listening doesn't say kick clients off. It says that we're no longer going to be actively listening for new connections.
Okay. When you say stop listening and then you set new port.
And then, okay, right, okay. Okay, I see your point. Your point is, if I say stop listening, then I set a new port, and then I say start listening again, what that means is I'm going to be accepting connections on a new port. Your question is, what happens to the existing connected clients? Okay? I leave that as a challenge to you to look in the documentation to see what the actual behavior is there. Because the theoretical behavior is that those connected clients should still be connected on the old port that they originally tried to connect on, and that should be the way it behaves. But I actually remember that we had some problems with the Java implementation of the system, and there were some little bits of behavior that we couldn't get to work in the theoretical way, and that might be one of them. I'm not quite sure about that. It might require that those clients get kicked off first. I'd have to double check that one. When we were writing this system, it took us 2-3 years to get the bugs out. Partly because to get it to work in all versions of Java on all platforms, Java 1, 2, and 3, and Unix and Linux and Windows NT and Windows 98 and later versions of Windows and so on. it seems to work on all the platforms, but we had to, some of the platforms, the Java implementations had bugs, and there were a few things that we didn't quite work properly in all the platforms, so we had to restrict some of the functionality, and I think that might be one of them. But the point is that if you use the normal, standard way of using the abstract server, you won't run into those kinds of exotic questions, okay? The normal way, you start listening, and then you stop listening when you're finished. Yeah.
Is it possible to change the course like this without your mechanism? Every 30 seconds or so, just change the word.
Yeah, that should be possible to do that. Yeah, but you can write your own code, right? You can write your own code that has a somewhere has a thread that every 30 seconds hits a timer and triggers some functionality every 30 seconds. And hey, that could change the port, So. Yeah.
About the close method, does it disconnect the client or?
Yeah, the close method disconnects clients. That's one of the key things that it does. Exactly. Okay, now we have a set of callback methods as well. Okay, so as before, we have some methods that may be overridden. Okay, and we have one that must be implemented. And there's a lot more here than there were on the client side. Okay. So, by default, all of these things do nothing. And you have the option of writing code that will do something interesting if you feel like. They get called automatically for you. Okay? So you just have to write code to implement them, otherwise you just get no behavior at all. First one is server started. Okay? This one gets called automatically by the code the code that's concrete in the abstract server level. Okay? Whenever the server is started up. Okay? As soon as the server is started, that one will get called. The second one will get called whenever any client connects. Whenever any client connects. That's interesting. So you might have a chat application and you want to be able to display to other clients when new clients are connected. So you could have some code that whenever a client connects, it will send a message to all the clients. It will call send to all clients and give the name of the new client. And so all the clients immediately know when any other client is connected. Client disconnected. Again, this by default does nothing, but you can get it to do some behavior, such as sending a message to all the clients saying, by the way, all the clients are disconnected. And that will again allow all your connected clients to keep track of who's on and who's not. Client exception is a bit like client disconnected, but it's saying some client rudely disconnected. Some client has just vanished from the network. We don't know why. They didn't call the method that they're supposed to call. They just seem to have dropped off. Their network connection has gone down or something like that, or their program crashed. Okay, so network connection gone down, client program crashed, whatever it is, that will cause client exception. And you can do the same thing as you would do with client disconnected if you want, but you could also do something slightly different. Instead of sending a message to all the other clients saying, this person has left, you could say this person vanished instead, that would give them information, that something happened over there rather than just gracefully leaving. Question?
You don't catch the client exception and server exception. Is your program going to crash?
His question was, if you don't catch a certain exceptions, is your program going to crash? Actually, if you look inside the code, you'll see that this thing called client exception is a method that is run. It is not actually an exception class. We, in the framework, do the catching of the exceptions for you, these kinds of exceptions. There are a few exceptions that you do have to try and catch, and you can see that. That's at another level of detail. But the mechanisms that happen when, the exceptions that get thrown when network problems occur, we have in our concrete code, in the abstract server class, we've written try-catch blocks for those. And so in our catch block, we're going to call for you this dummy method, hook method client exception that you can write code for. Okay. So we've simplified a lot of the exception handling stuff for you, and when that exception is thrown, you don't even need to know about it. You just can implement this client exception, and it will do whatever you tell it to do. We've made your job simpler for you. Another one of these methods that may be overridden, these hook methods, is server stopped. Okay, so server stopped is called whenever the server stops. You know, you say, in fact, if we go back, we say stop listening. Well, you know, server stopped is simply the method that gets called by the system whenever you call stop listening to confirm, in fact, that it actually did successfully stop. Listening exception, on the other hand, may be called at any time. And listening exception occurs when something strange goes on. Maybe your server is cut off from the network. Okay? So if my server is cut off from the network, not only can't I, not only are my clients cut off, but at the same time, I'm no longer really listening for new clients, right? You know, if my IP connection is severed, you know, then I'm also really no longer listening. So listening exception is thrown at any point in time when I'm cut off from, and I'm actually no longer listening and accepting new connections due to network problems. And server closed is called whenever I'm not only not listening anymore, but I've also shut down all my clients. So I've got nobody connected anymore. And that is called when the process of close gets through to completion. Okay? So these are all things that I can get to do interesting things, typically display information on screens, or maybe send messages to clients, that kind of thing. But by default, they do nothing. You have to write code in your subclass for these, if you want. Question? Yeah?
In terms of client disconnected and client exception, ultimately they both refer to the same thing when your client is not there anymore. So
Yeah.
Can we just simply use client disconnected and in that sense make sure that whenever we don't see the client anymore, be it disconnected or not?
Her question was, well, why don't we just use, could we just use client disconnected and forget about client exception? And the answer to that is that one or the other will get called, depending on the severity of the disconnection. Normal disconnection, you'll get client disconnected. Severe, unexpected disconnection, you'll get client exception. And so you need to implement them both. Maybe they both call the same method if you want to do the same thing. But we originally had, in our first design of this, there was one. There was one method. And then we decided that and that one method, then we said, well, we could add an argument. One method with an argument that says whether it's a bad disconnection or not. And then we decided a cleaner design would be to have the two, because very often the kind of things that you want to do is somewhat different depending on whether it was an exceptional or a normal disconnection. And there's no arguments, it just says client. Well, actually, the argument is the client, the disconnected, so you know who it is. But the argument is information describing the client. I mean, not really the client, because the client is over on the other side. So there are two methods, and you have to implement them both if you want to detect all of the possible clients that are no longer there. But that was a very good question. Okay, now, we also said that there was this class called connection to client. Okay, so we've got abstract server, and now we've got connection to client. Connection to client is not abstract. Connection to client is concrete. You don't subclass it, though. It's a concrete class that is part of the framework that you just use the facilities of. You will, in some of the methods that we just looked at, be given an instance or instances of connection to client. And you can do things with them. When you have an instance of connection to client, in a variable, you can say, send to client. If I have an instance of this, I can say, send to client, and the server will dutifully send off an object to that client. Or I can say, close, and that will boot off that client. So I can do two things. I can send a message to it, or I can kick it off the system. Okay? Either of those two things. I can also find information about it. I can find its internet address. Okay, what is the IP address of this client that connected to me? Could be very useful for such things as, seeing where they came from. For example, if you connect to the Google search engine, it knows which country you live in. And how does it know which country you live in? Because it looks at your IP address and says, These are IP addresses assigned to Canada, and so it'll just say google.ca, or if you're in some other country, it'll have the relevant version of Google. Try it, you'll see. It knows where you are. Okay? and it does that because anytime a server gets a connection from a client, it knows the internet address, and if you can figure out from a table where that internet address was registered, you know where they're coming from. You can do other things with the internet address too. You can keep logs of where your clients are coming in from. You can try and detect intrusions, people you don't like. If somebody's hacking into you from a certain place, you can start systematically rejecting connections from that. Either that single address, or maybe the whole subnetwork, right? Because the addresses are broken down into subnetworks, and you can figure out what network somebody's on, and you can just exclude an entire network by looking at the internet addresses if you want. So there's that, and then there's a thing called setinfo and getinfo. These are very important pieces of code that you're going to be using extensively. In short, what setinfo does is it says, save a piece of information about this client that we can get later on by calling getinfo. So for example, I could save the login ID. So a client connects, and all I at that point in time have is an instance of connection to client. I know what its internet address is, I know nothing more. So I'm waiting, and I've got this connected client sort of in a transitory state. At some point in time, I'm going to get messages coming in from that client. And I might say, okay, the first thing that this client is going to have to do is send me their login. And I'm going to validate that login. And if I don't get a valid login, I'm going to call close and say goodbye. If I get a valid login, then what I might do is I might say, okay, got a valid login. Next thing, the next message that must arrive is the password. Okay? And if they don't send me a valid password, I'm going to call close. But when I get a valid login and the valid password, I might say, I'm going to save the information by saying setinfo and the name of the login. So later on, when the system's been running for 10, 20 minutes, and an instance of connection to client shows up somewhere, I can say, getinfo, who is this? By login ID. Rather than just looking up their internet address, I can say, what's the login that they used when they logged in? But I can also save other information as well as the login. I could save information about, how many messages they've sent, or whatever I felt like. In fact, I could save anything I felt like about a client using setinfo and getinfo. These things allow me to save an arbitrary object associated with the connection to client that is part of my application. Okay? Question?
So where would you send and get information from? A database?
This could be information that you've retrieved from a database, but the actual setinfo is stored in the running system. Okay? It's stored in the instance of connection to client in this running thread that is the connection to client. And basically, every now and then, some of the methods will return a connection to client, and I can say, getinfo, to find out information about them. We'll see the mechanism in more detail in a while. Before I do that, however, let's just take one more look. Connection to client is an instance, it's a concrete instance you're going to get for every client. And going back, okay, client connected, client disconnected, client exception. Okay? All of these things will give me an instance of connection to client that tells me who it was that connected, who it was that disconnected, who it was that disconnected in an exceptional way. So that I can say, oh, well, it was this user that disconnected. And I can send messages to maybe all my other clients saying, it was Jim Smith that was the one that disconnected. Okay? So I get that instance given to me by these messages. These overridden messages, and I can do something useful with that information if I want. Okay? And when I call get client connections, what I get is an iterator that iterates over the get of the client connections. So if I say get client connections, I get an iterator, and then I say next, 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 next. Each of those nexts will give me an instance of connection to client, and then I cast it, because then the next operation on an iterator will simply return me an object. I've got to cast it to connection to client. I know that's what it is. And then I can call getInfo to find out who it is, or I can call send to client, or I can call close, or whatever I felt like. Okay. So you will, in your code, be working with instances of connection to client because you'll be passed them as data when you call some of the other methods. Okay? Question?
Is connection to client abstract or is it actually?
Connection to client is not abstract, it is concrete, but you don't subclass it and you don't change it. It is there, you don't do anything with it. You just work with it as is. Okay? Some people say, well, why don't we subclass it to add extra facilities? Well, there's no extra facilities you need to add to it. Because if you want to save information, like one of the reasons to subclass is to create additional instance variables. But you don't need to create instance variables in this. That's why we provided setInfo and getInfo. Effectively, what this gives you is the same kind of capability as if you had instance variables. You can set values that have particular information in them using these two methods. So, as a software engineer, how do you use abstract server and connection to client? Well, first of all, you create a subclass of abstract server. This is your application code that does your server functionality. You implement the slot method handle message from client. Okay? But this is, so far, it's very similar to what you did on the client side, right? You create a subclass and you implement this slot method. Handle message from client is saying, okay, we're providing the language that the client will, the server will understand, that the client will send to us, and this is what the server does. This is the services that the server provides to the client. Handle message from client does all of that, or calls methods, other methods that do all of that. Handle message from client is the central server functionality. It gets passed an object every single time a client sends a message to the server. A connected client sends a message to the server. And we can do what we want with that object. That's up to our application. If it's a string and it's in a chat program, it might be just sent to the destination client that it's supposed to be routed to. So the string might say, here's the name of the destination, here's the message, and the server's job is then to look up that name of that destination by looping through all the connections to clients, find a matching person, and then send the message on to that connected client. Okay, that's basically the way an instant messaging system works. If it's a chat system, which it is in the very first version of Simple Chat, all it does is as soon as anything comes in to handle message from client, it just sends it to all the clients. So the simplest implementation is send to all clients the argument. That's it. There's nothing else. Okay? As this course goes on, you're going to be turning that very, very trivial implementation of handle message from client into a much more sophisticated system that does all kinds of powerful stuff, like forwarding and setting up channels, and eventually, if you do the bonus question, sending pictures. Okay, so we've created a subclass, we've implemented handle message from client. Then we're going to move on and we're going to write some code that does some useful things, because until this point we actually haven't got an instance created, so we've got to say create an instance of our application subclass somewhere. There's got to be code that does that. We've got to call listen somewhere, otherwise we're never going to start accepting connections. And somewhere, presumably, we're going to be sending messages to clients. There's absolutely, I can't see, well, except in extremely eccentric cases, there's no point having a server if you're never going to send any messages to clients. You know, at the very least, a client sends you a request and you send an answer back. It's pretty unusual, again, to have a server that just will accept messages from clients and never respond. But I could imagine some strange system that would do that, you know. But generally speaking, you're going to be sending messages from clients, and you're going to be sometimes sending messages to all clients. So you might say get client connections to get the list of them, the iterator of them, and then send to all of them. Or you might just send to one particular client that you want, that is distinguished in some way, has a particular meaning to you. And if your job is to send to all of them, you can just use this. Send to all clients, effectively all it does is it iterates through the the client connections, and call send to client. So send to all clients is simply a utility that does this all in one step. And you implement one or more of the callback methods that we talked about, if you want. Okay? So that's how you use this to create an application. Relatively straightforward. You don't have to know anything about sockets or IP addresses or TCP/IP or any of that kind of stuff. You just have to know there's a few key things you have to do. Here they are, all on one page. Yeah?
Practically speaking, it's going to be quite impossible, but what if, theoretically speaking, you have two messages from two different clients at exactly the same time? How can your server handle that?
Okay, her question is what if you had two messages coming in from two clients at the same time? And she says that's a practical issue, maybe it's theoretically impossible. Well, the answer is that the network will automatically send a packet at a time into your client, right? So there will always be a sequence. But let's imagine on the theoretical issue that it was possible. You had two network connections and it was possible to get them at the same time. It still wouldn't be a problem because you have a separate thread handling each connection to each client. And those threads, the operating system will take care of the, of which one runs when. And you're just never going to be a worry. The system will automatically put one before the other.
But you have a thread once the client is already connected, right?
Yeah, when the client...
I'm saying, what if the request is to connect?
The request is to connect. What if you have two simultaneous requests to connect? Well, okay, that is a theoretical issue. In practice, they will be sequenced. The operating system will deliver one first, then there will be some brief processing as you go around the run loop in that thread to accept the connection and set up the new thread. If another thread has come in, within microseconds, if another request has come in to connect, there's a queue. There's a backlog. Eventually, the next connection will get accepted and the loop will go around again. It is possible that 10,000 clients all try and connect at the same time, as in some kind of distributed denial of service attack, which is one of these problems that some hackers try and do. If that happens, it will overload your server's attempt to accept connections. And what you'll get is those clients that try to connect laterally will exceed the length of the queue, and the operating system will just say the server's not responding. So server not responding will be what those clients will see. Okay? And in the client side, an exception will get thrown when that happens. Okay? So that's the mechanism that goes on if the exception mechanism gets overloaded, which can happen. Okay? But we're not going to worry too much about that right now. But you can see that you will be able to take a look and see the mechanism. Some of the documentation describes how some of those things get handled. But it's not something you need really to worry too much about. As a client trying to connect, there's all kinds of reasons why you might not get service. You might not get service because the server's not running at all. You might not get service because the network is down. You might not get service because the server's not listening. You might not get service because the server's overloaded and it's listening, but the queue of attempted connections is so big that the operating system's not even letting it get through to the server. Okay? All those things could happen. From the client's perspective, all it sees is, I can't connect. Okay? Yeah?
Are there real systems or companies actually using this framework?
Are there real systems or companies using this framework? The answer is not that I'm aware of. We wrote this as a framework for the use of for the academic use, and that's it's strictly written for this course, this book. It's available for other people to use if they want. There are other frameworks that have similar functionality that I've seen published. IBM has a framework that does something very similar to this. But this was written for use of students. There would be no reason why it couldn't be used. I wouldn't object to anybody using it. There's a shareware license associated with it if people wanted to use it. Okay. Somebody else had a question? Yeah.
Can we merge the abstract server and abstract client into one class? And when we want to run the program, create a server and the client at the same time?
Okay, his question is, can we... Well, I'm going to split your question into two parts. Can we, in a single program, have a server and a client at the same time? And the answer is absolutely yes. Okay? A peer-to-peer system would have a client component and a server component. In fact, it might even have more than one client component. I could be a client to several different servers, and I could, if I wanted to. And in which case I'd have to have several instances of my concrete subclass of abstract client connected to different servers. I could do that, each one with its own thread, each one with its own instance. And I could act as a server. I could actually, if I wanted to, I could have at the same time more than one instance of abstract server going at once, each one being its own thread. I'm not quite sure why I'd want to do that, but I could imagine certain sophisticated architectures where I was listening to different languages at the same time. There could be certain cases. The original part of your question was, can I merge these into one class? The answer is no, because basically we've already split server into two classes because each class has got one kind of thread functionality. The one that's accepting connections, the one on the server side, the one that is talking to clients on the server side, and the one that is talking to servers on the client side. And so each of those has its own thread implementation. So in order to merge functionality, I just have multiple threads and have all the threads going at the same time.
So I can't have multiple threads in just one class?
The answer, no. It can't have each thread is got one. Each thread class has got one run method. That run method defines the operation of that class, okay? And I can't have more than one run method. That's basically the gist of it. And that run method is going to go around and wait for something, and go around and wait for something again, and that thing it's waiting for defines the functionality of that thread. So I'm waiting for a connection, or I'm waiting for a message. All right? Very good question, though. Any other questions? All right, let's take a look at the internals. A couple of key pieces of the internals, set info and get info. They make use of a Java class called a hash map. We won't worry too much about this. I leave that up to you to investigate. It is an interesting class, an interesting data structure class that is used to allow the storage of information where you have a key and a value. So the key might be user ID, the value is whatever the user ID is. The key might be another key might be password, the value is whatever the password is. Another key might be number of messages sent, the value is that number. So I can store a key and a value. The key can be any object, typically using strings. The value can be any object. So I can store key-value pairs of different types of information. So effectively what I can do is I can simulate the effect of having any kind of instance variables I want, except that instead of being efficiently stored as instance variables, they use a mechanism that's a little bit more sophisticated and a little bit less efficient, called a hash map. So I can simulate the effect of instance variables without having to create all kinds of different subclasses of connection to client. And the reason why I don't want to create all kinds of different subclasses is because then I'm going to have to modify the code of my abstract server to know which subclass is being used. That would have been an alternative design, but we decided to go this way. So you can use, to store simple things like a user ID, you can use this set info, get info mechanism. And I leave it up to you to see in the lab how that works. It's fully specified in the lab. Many of the methods in the server side are synchronized. Synchronized says we cannot run more than one method on this object at the same time from different threads. We cannot run more than one method on this object at the same time from different threads if those methods are synchronized. Okay, so two synchronized methods have to wait for, one has to wait for the other to complete working on a given object before the second one can operate. That becomes important to prevent certain kinds of strange bugs, where, for example, I have one thread connected to one client that is fiddling with the data, and another thread, another connection client thread that's on a different client, fiddling with the same data at the same time, and sort of one overwrite the data the other one has written. So if a message comes from a client and I want to change information in the server, I have to make sure that that is done quickly and rapidly in a synchronized method and then over with, so that other clients that are trying to also fiddle with the same data can then come in and do their job. Otherwise we get a mess and we get bugs coming in under heavy use of the system. Attempts for simultaneous access from different threads. Okay? You don't have to worry too much about that, but you will see this, and it is important for you to have a conceptual understanding of why some things are synchronized. A lot of the work we did in debugging this system was to get the synchronization right. Synchronization in Java, it takes a lot of overhead, it takes a lot of work, okay, from the virtual machine side, and so you don't want to overuse synchronized, but it is an important facility. Another thing which you'll see is that there is a thing called a thread group, which contains all the instances of connection to client inside the system. Thread group is a built-in mechanism in Java that keeps track of multiple threads, and it's sort of hidden from you if you're using the framework, but look inside the internals to see kind of the facilities it provides for you. It does such things as detecting when one of these threads dies because the run method ends and things like that, and dropping it off the group and things like that. And another thing is that there is a mechanism that that pauses listening every 500 milliseconds, ever so briefly, to see if stop listening is being called and then resumes listening. You might say that's strange. Why does it do that? It's because of the internal mechanism within Java. That's necessary. It actually has no effect on the use of the system. You don't even know that has to go on. It pauses listening for very briefly, starts listening again. That doesn't mean that clients get a message back saying server's not listening, because the client, when it tries to connect, will wait just ever so short while, and eventually it'll get in after this check has been done. Okay? But you don't have to worry about that, but if you look inside, you'll see that going on. Okay? Question? He says, would that not make it inefficient for a large amount of data transfer? Any mechanism of any kind will reduce the capacity of a system for a large amount of data transfer. This is a necessary part of the functionality of the system. You can't avoid it. We tried to avoid it originally. But any execution of any kind will slow. Every system's got a capacity. One of the things you have to do as software engineers is understand our capacity and deal with that. One way of dealing with capacity is to get it running on a faster machine. Another way of dealing with capacity problems is to actually have multiple servers. So, for example, if you connect to CNN, CNN has a front end that distributes your connections to different servers that all provide equivalent functionality. Yeah?
Can we implement the same thing if we use the exception whenever servers stop listening for exception, this one will catch it?
I'm sorry, I have no idea what you're trying to ask there. Can we... I want to get to the end of this lecture, okay? It sounds like a sophisticated question. Let's leave that and catch it offline, because I think I've explained everything. It's probably something that you didn't quite catch from what I've already explained. So ask me that offline or by email, and I'll get you an answer once I understand your question. Okay, in the last couple of minutes, I want to just briefly show you how we have actually made use of this in our instant messaging application called Simple Chat. Okay, so in Simple Chat, we've got an abstract client and abstract server. On the server side, we've got connection to client. I'm not showing it here, but it's there anyway. Some class of abstract server is a thing called Echo Server. It's called Echo Server because all it does is it says, here comes a message coming from a client. I'm going to echo it back to all the clients. That's all a handle message from client does. And it will also do something interesting with server started and server stopped. It'll just display a message on the screen. It's got a main program that will create an instance and fire the thing up, okay, and start listening, okay? So that's all it has. On the client side, I've got a thing called Chat Client. Handle message from server does nothing but display, and it calls the display of a thing called Client Console. So this piece of code here, Chat Interface and Client Console, is code that I have on the client side that is completely application. It's nothing to do with OCSF. It's part of my client implementation for chatting. And in fact, we have our own, I've separated the user interface code from the application, the core application code. This is my core client, abstract client, chat client, and chatif, client console on my user interface side. Okay? Now, because time is limited, what I think I'm going to do right now is I'm going to sort of say, go and study this and understand how this goes, and next day we're going to pick up and we're going to talk about the simple chat system on the next class. Okay?